Okay, this will be the last video dealing with exponential and logarithmic functions. In this lesson 2.7, we'll be dealing with compound interest, and we'll actually be applying some of the techniques that we use with exponential and logarithmic functions. So let's look at the formulas that we're going to have in this lesson. Now, compound interest can be compounded annually, that's once a year, semi-annually, twice a year, quarterly, 4 times a year, could be monthly, 12 times a year. You could have it daily. You could even have it every instant or every second. Now, the first formula that I'm going to look at is for compound interest, and you invest a principal P. This is some amount for T years at some rate R, compounded N times a year. Okay, so that means at the end of each period, the interest earned is converted into principal. So the principal keeps growing, unlike simple interest where the principal stays fixed. Okay, so in the first formula we have future value. You invest a value an amount P for T years at R, compounded N times a year, and you get this future value. Now the present value for compound interest is simply taking formula in part A and solving for P. Okay, so all I did is I took the formula in A and solved it for P, and I get P is equal to A over 1 plus R over N to the NT power. Okay, so these first two formulas deal with interest where compound interest where it's compounded say annually, semi-annually, quarterly, monthly, daily. Now if you have interest compounded say every second or every instant, then it's going to be continuous compounding, and that'll be the formula that I have here in C. Continuous compounding. A is equal to P, that's the amount invested, and E of course is your exponential, and the exponent is again RT. R is the rate of compounding, and T is the time in years. And then again, to get the present value, I simply take the formula on C and solve it for P, and I get P is equal to A to the, or A over E to the RT. Okay, so these are the formulas that we're going to be using, and I will be using my graphing calculator to solve most of these problems, or actually all of the problems. Okay, so the first one here that I have is find the amount that results from each investment. So $300 invested at 7.5% for 4 years, compounded quarterly. Okay, that's every 3 months, so it's 4 times a year. So using the first formula, I'm going to use my calculator. Okay, so the first formula for the here I'm finding the future value is what I'm doing here. So it's $300, and that's multiplied by 1 plus, and then remember it was the interest rate over the frequency of compounding. Okay, so this is going to be 7.5%, but it has to be converted to a decimal. So move the decimal over 2 places, I get 0.075, and then I divide this by the frequency of compounding. So it's compounded quarterly, so this is divided by 4. Close parentheses, and then the exponent is N times T. Okay, frequency of compounding times the number of years. So that's how we get the 16 here. Okay, 4 times the 4. So this is 16. Hit enter, and I get 403.83. Round off to 2 places, and that's in dollars. Okay, so that tells me then that if I invest $300 at 7.5% for 4 years, compounded quarterly, that is, I let the money sit there, I don't make any withdrawal or deposits, then in the 4-year period, I come up with $403.83. Okay, so the 103.83 is my interest generated. Okay, same thing in the next one. And this one, though, it's compounded continuously. So it's $500 invested at 6.7% for 6 years, compounded continuously. Okay, so that's going to be formula C here. Continuous compounding. A is equal to P E to the RT. Okay, so you see the setup that I have there. That's how I got the answer. And then let's do it for you in the calculator. So it's $500, and then that's times the exponential e. So I hit second and then ln to access the exponential e. There it is, and then I enter it. Interest rate. So I'm just multiplying the interest rate according to the formula times the number of years, and I'm just going to let the calculator do it all for me. So I'll put 0.067 times 6. Close parentheses, hit enter, and I get 747.41. Okay, that's in dollars. Okay, so these are finding future value. You make an investment, you let the amount sit there, and you generate a future amount, which of course is the original principal plus the interest earned. Now in the next one, it's find the present value. Okay, so present value, I'm going to be using formula B here. If it's regular compounding, if it's continuous compounding, then I'm going to use the formula here in D. Okay, so find the present value of $200 after 3 years at 5% compounded daily. Okay, so the $200 that they give you here is actually the future value. So what they're asking you is really, what do you invest now, so that in 3 years you'll have the $200. Okay, so the setup is, again, the future value A, that's $200 divided by this expression here. So I have 0.05, and then the frequency of compounding, it's daily. So that's 365 days in a year, so that's 365. And then the exponent is going to be 3 times the 365. Okay, so just using the formula for present value for compound interest. Okay, so let's set it up here. So $200 divided by, okay, parentheses, so I have 1 plus 0.05 divided by 365. Okay, so let the calculator do all of that for me. Close parentheses, and then my exponent is going to be, okay, I'm gonna enter it as 3 times 365 like I have it there. You can go ahead and multiply it ahead of time and then go ahead and do it, but I'll just let the calculator do it. So I'll put parentheses here. So 3 times 365. Close parentheses, hit enter, and I get 172.14. So $172.14. So what this is telling you is that if you take $172.14 and invest it for 3 years at 5% compounded daily, then at the end of the 3 years you'll have in your account $200. Okay, so it's a 172.14 you put into it, plus the interest generated over that 3-year period, and that's going to give you $200. Okay, let's clear this. Same thing for the next one, except it's compounded continuously. So it's $1,000. We want to find the present value of $1,000 after 5 years at 7% compounded continuously. Okay, so I'm using the formula for continuous compounded present value. This will be D right here. P is equal to A over E to the RT. Okay, so there's your setup. 1000 divided by e to the 0.07 times 5. So did this in the calculator, so this is your setup here, and then here's the calculations. 1000 divided by, again, exponential, and that's 0.07 times 5. Close parentheses, hit enter, and I get 704.69. 704.69. Round it out to the nearest cent, which is what you usually do with when you're dealing with money. Okay, so what this is telling you is if you take $704.69 and invest it at 7%, compounded continuously, let it sit there in the bank for 5 years without withdrawing or making any deposits. At the end of the 5 years, you'll have $1,000. Okay, let's clear this. Now, in this one, they're asking how long does it take for money to double at 4.5%? Okay. How long does it take for money to double at 4.5%? And for A, they want to know, okay, the situation if it's compounded quarterly, and B, if it's compounded continuously. Okay, so your formula is, notice in this case, you don't know what the amount is. Okay, it could be, how long would it take $20 to double? $100 to double? It doesn't really matter because of the setup. Okay, so for part A, here's the situation. Compounded quarterly, the setup would be this. It would be P, that's the dollar amount. Parentheses, 1 plus 0.045 over 4, okay, this is compounded continuously. And here in the exponent, what we're looking for is the number of years. How long does it take? Okay, so we're looking for time. So the thing that's not given here is time. That's what we're looking for. Okay, so this is your setup. And see, the reason you don't have to know what the actual amount is because notice I have a p on both sides of this equation. So those are going to cancel out. Okay, those are going to cancel out. Okay, so this P and this P cancel out. So that leaves me with this formula right here. Okay, so now what I want to do is I want to solve for t. Okay, so I'm going to use the same techniques we used when we were solving exponential equations. I'm going to take the log of both sides. Okay, so I'm going to take you can use ln or you can use the log base 10 or base c. So I'm going to take the log of this side and the log of this side. Okay, so here's what I'm going to have. I'm going to use ln. So it's going to be the natural log of 2. Okay, now over here on this side, I'm going to take the natural log of this side, but remember, using properties of a log, this exponent here will become a coefficient, so I'm going to put it over here. And then this will be ln of that expression right there. So 1 plus 0.045 over 4. Okay, so that's your setup. That's the setup for the equation. Okay, so what's going to be? Okay, so what I'm going to do, I want to solve for t. Okay, so first let's isolate this expression right here. Okay, so if I divide both sides by the natural log, okay, and I'm going to do it in the calculator here. Easier for me to do it this way. Okay, so here's what I'm going to have. I'm going to divide both sides by the log of this expression right here. Okay, so what this is going to give me then is going to be ln of 2 will be divided by, okay, I'm going to divide both sides, okay, so I'm going to divide by ln of 1 plus 0.045, and that's divided by 4. Okay. Hit enter. Okay, so what do I have then? That's going to give me then well, let me do it this way. This 4t then, because I divided both sides by that, 4t will equal to this number that I have over here. Okay, so that's going to be 61.95901011. Okay, so now to solve for t, then I just divide both sides by 4. So I'm just going to divide this by 4. So I'm going to say divide by 4, and I get 1549 to 2 places. Okay, so in this particular case, then I can say then that t will equal to 15.49. And this is of course years because it's t. Okay. So this is telling me then that any amount that I have will double in 14.49 years. So this would mean, say I had $10. Say I had $10, and the inflation rate was 4.5% compounded quarterly. Let's say that was the inflation rate. If it stays constant, then in 15.49 years, the amount, say $10, will double to $20. Okay, any amount. Okay, that's clear of this. Okay, the next one is saying the same thing, except what is it if it's compounded continuously? Now there's not going to be that much difference because it's again the same interest rate. The only thing that's changing is the frequency of compounding. This one is compounded quarterly, and this is continuously. Okay, so again, just like in the other one, I start off with the formula for continuous compounding, and that's P is P times e to the rate 0.045, and the time is t. That's the unknown. I want to know when this amount will double. Okay, so I start off with P, so I want to know when is this going to equal to 2P. So that's your formula. Now they asked you how long would it take for the amount to triple, and the only difference is you'd put a 3 over here on this side. Everything would be the same. So these p's cancel out here, and you get this right here. Okay, so just like in the part A, I'm going to take the natural log of both sides, and in this one it works out even nicer because the base here is e. So because I'm taking the natural log, okay, so this is ln here, and in this case, I can make room over here, ln here, taking the natural log of both sides. Because the base here is e also for the log, the left side simplifies to 0.0. 4, 5 t. And the right side is natural log of 2. Okay, so all I have to do then is divide the ln of 2 by 0.045. Okay, and if I do that, then I get t is equal to 15.40. Okay, so notice there's not that much difference. This one is 15.49 years, and for part B it's 15.40 years. And you expect it to be a little bit less because the frequency of compounding is more frequent. So it's going to double a little bit quicker than at the other frequency of compounding. So this is a solution to this. Okay, this will be the last video on this series dealing with exponential and log functions. And the next series of videos, I'll be looking at what amounts to Chapter 3 of our college algebra course, which would deal with systems of linear equations, matrix algebra, determinants, and so forth. So please subscribe, and we'll see you in the next video.